Hello students, welcome to Studi.Live. Students, here we will be revising with chapter called as amine. It is an organic chemistry chapter, students. Now students, what are these amines over here? You say amines are what? It is going to be derivatives of what? Ammonia. Okay, in this chapter we will be learning what are amines, what are the various types of amine. Okay, then we will be dealing with its nomenclature. Then we will be talking about their methods of preparation, their physical properties, and then students along with their chemical properties. So here the topic is going to be what are these amines. So you say students, amines are what? They are nitrogen containing organic compound having which character? Having basic character. So you say amines are going to be what? Amines are nitrogen containing organic compounds having which character? Having your basic character. See students, this word is important. They are going to have which character? They are going to have basic character. Now where these amines are what present, students? You see they are present in nature. See, they are present in the structure of many natural compounds. See students, these proteins, they are going to be what? They are going to be nitrogenous compound. Okay, they are going to be amines. Vitamins is what it is, a structure, okay, where these amines are formed. They are present in hormones, students. You can find them in many plant products like what? Like your nicotine. Now students, how these amines are classified? So here students, what I'm going to do is, the other thing which I'm going to say, I say this is going to be my ammonia. Yes, here there is going to be your ammonia. What I'm doing is, I'm removing one or more hydrogen atom of ammonia by which group? By alkyl, or you say by aryl group. So what you get is, either you get what? You get alkyl amine, or students what you will get? You will get aryl amine. So you say they are obtained from ammonia by replacing one or more hydrogen atom of ammonia by alkyl or aryl group. So this is going to be what? This is going to be your amine over here. And what is this, students? It is going to be your ammonia. Now students, if you are replacing one hydrogen atom of ammonia by one alkyl or aryl group, you will get primary amine. If you are replacing it by two alkyl or aryl group, if you are replacing two hydrogen atom by two alkyl or aryl group, you will get secondary amine. And if you are replacing three hydrogen atom of ammonia, all the three hydrogen atom of ammonia by alkyl or aryl group, you will be getting which amine? You will be getting your tertiary amine. So students, here you say these amines, they are classified into what? They are classified into something called as your primary amine, then there is secondary amine, and then there is going to be what? It is going to be your tertiary amine. So students, here what I do, I call it as RNH2. Then there is going to be what? There is going to be RNHR dash. And then students, here it is going to be your R1. This is going to be your R2. And then students, here it is going to be your R3. So students, here what we have seen is these amines. When you talk about amine, you say these amines are what? They are classified as primary, you say secondary, and the another one is going to be what? It is going to be tertiary amine. And how they are obtained? By replacing what? By replacing one or more hydrogen atom of ammonia by which group? By alkyl or aryl group. Now students, if you see carefully over here, what we are going to do is, we say, see here there is only one alkyl group. Here there is going to be only one alkyl group. But here there are two alkyl groups. Those two alkyl groups may be same or they may be different. Here there are three alkyl groups. They may be what? They may be same, or they may be what? They may be different. So on that basis, you classify them further into what? You classify them further. Secondary and tertiary amine are further classified into what? Simple, that is symmetrical amine, and you say mixed, that is going to be your unsymmetrical amine. Yes students, if they are similar, you call them as simple amine. If they are different, you are going to call them as what? You are going to call them as your mixed amine. Now students, the another important class is going to be what? If alkyl group is attached to nitrogen atom, you call it as aliphatic amine. And if aryl group is attached to nitrogen atom, you call it as what? You call it as aromatic amine. So you say amines are also divided into two major classes, namely aliphatic or aromatic amine, on the basis of what? On the basis of the group which is attached. If alkyl group is attached, you call it as alkyl amine. If aryl group is attached, you call it as aryl amine. That is going to be aromatic amine. Alkyl amine is aliphatic, aryl amine is aromatic. Then students, here what we are going to do is, we say there are three types of what? There are three types of amine over here. Okay, you have what? You have three types of amine, students. You say there is primary amine, there is secondary amine, and then there is tertiary amine. Primary amine is also known as 1 degree amine, secondary is 2 degree, and tertiary is going to be 3 degree. Here there will be only one alkyl group attached. So the functional group is amino, here functional group is imino, and here the functional group is what? It is tertiary nitrogen. So students, here what I say is, here what we have learned, students, in our topic is what? You say amines are classified into primary, secondary and tertiary. Primary amine contain amino group, secondary contain imino, and tertiary contain what? Tertiary nitrogen. Okay, and then students, their representation and then their examples we have understood over here. Okay, it is going to be what? It is going to be your ethyl amine. Okay, it is going to be your ethyl amine. Then it is dimethylamine, and then here it is trimethylamine. This is the example along with what? Along with their common name. Now students, here the another important thing which we are going to talk over here is, you say like alkyl halide or alcohol. See, when I say alkyl halide, this is going to be my alkyl halide. Now alkyl halides are classified into primary, secondary and tertiary. See, you say you classify them into primary, secondary, tertiary. Alkyl halide or what? Or your alcohol. They are classified into primary, secondary or what, students? Or you say tertiary, on the basis of what? On the basis of type of carbon to which alkyl group is attached, or on the basis of type of carbon to which this halide or hydroxyl group is attached. But in case of amine, student, we don't look at the type of carbon. We look how many alkyl groups are attached on nitrogen atom. So students, you say like organic compounds like alkyl halide, or you say alcohols, they are classified into primary, secondary or tertiary, depending upon what? Depending upon the nature of carbon atom to which functional group is attached. But that is not the case in case of what? Amine. Amines are classified depending upon what? Number of alkyl or aryl group directly attached to nitrogen atom. See, if there is only one alkyl group, it is going to be primary. It is going to be your primary. If there are two alkyl group, you say it is going to be what, students? See, if there are two alkyl group, students, you are going to call it as secondary. And if there are what? If there are something called as, see students, here what we say, if there are three alkyl groups, then you are going to call it as what? You are going to call it as tertiary. Now students, what I am going to do is, see, if you see carefully over here, see, we are talking about example over here, students. See, I say there is CH3, this is CH, here it is CH3 and here it is OH. See students, if this alcohol is written, it is going to be secondary alcohol, because in case of alcohol, you look upon the carbon to which functional group is attached. तो here secondary carbon पे functional group is attached. So बच्चे ये क्या हो जाता है? ये secondary alcohol हो जाता है. बट अगर आप अमाइन की बात करते हो, अगर इसी केस में मैं अमाइन लिखूं, अगर मैं इसको ऐसे लिख दूं बच्चे, यहाँ पर OH की जगह पे NH2 डाल दूं, तो ये क्या हो जाएगा बच्चा लोग? OH की जगह पे हमने क्या लिखा है? वी हैव रिटन विथ व्हाट? NH2. तो ये सेकेंडरी अमाइन नहीं होगा बच्चे, ये कौन सा अमाइन होगा? ये प्राइमरी अमाइन होगा, क्योंकि अमाइन में हम देखते हैं कि कितना हाइड्रोजन एटम अमोनिया का रिप्लेस हुआ है. ओके, अमोनिया का एक ही हाइड्रोजन निकालकर एक अल्काइल ग्रुप इंट्रोड्यूस किया है बच्चे. We don't see कि NH2 is attached to secondary carbon. We see how many alkyl groups or aryl groups have been attached to the nitrogen atom. So here only one hydrogen atom of ammonia is replaced by isopropyl group. So it is not a secondary amine. It is a primary amine. So students, this is a point which you are supposed to note properly. They ask you question based on this in your entrance. So either here also students, they have taken example. Isopropyl amine is going to be what what? Primary amine. But isopropyl alcohol is which alcohol? It is going to be your secondary alcohol. Now students, here what I am going to do, I say in case of nomenclature students, what happens in case of nomenclature? Amines, there are two types of name. One is going to be common name and the another one is going to be what students? It is going to be your IUPAC name. So students, here what I do is I write over here amines. Okay, here I'm going to talk about what? Their common name, and then students, here I'm going to talk about what? Their IUPAC name. Okay, I say there is RNH2. So students, what is going to be the common name? It is going to be your alkyl amine. And what you say students, and here what is going to happen? Here IUPAC name will be obtained by replacing what? E of alkane by what? By amine. Okay, so students, for primary amine, common name is going to be alkyl amine and IUPAC name is going to be alkane amine. Alkyl amine is obtained by prefixing alkyl group to what? Amine, and alkane amine is obtained by replacing E of alkane by what? Amine. Now students, here there is going to be what? It is going to be your secondary amine. See, secondary mein what you say, there are going to be two cases students when you talk about secondary. See, if R is equal to R dash and R is not equal to what? R dash. So students, here you call it as what? Your dialkyl amine, and here students, it is going to be what? It is going to be your alkyl amine students. It is going to be your alkyl amine. Both these alkyl group has to be in which order? They have to be in your alphabetical order. Yes, they have to be in which order? Alphabetical order. But if I just want to talk about students, what name? Their IUPAC name. So here it is going to be your N-alkyl alkane amine. Here you are going to write it as what? N-alkyl alkane amine. These students, it goes in this way. There is RNH2. What is that? It is alkane amine. The name is going to be what? It is going to be alkane amine. Now, what you are doing is, from here, one H has been replaced. Let us say by R dash. So, you say it is N-alkyl and then the rest is going to be what? It is going to be alkane amine. So, if it is common, no problem. If it is mixed, students, what you are supposed to do? If it is mixed, you say it is N-alkyl alkane amine. This, see here what we are going to do, students. This has to be what? This has to be your longer one, and this has to be what? It is going to be your shorter one. Yes, students, now they say here what I am going to do is I am going to talk about my which amine? I am going to talk about my tertiary amine. See students, if R1 is equal to R2 which is equal to R3, you call it as what? You call it as trialkyl amine. Okay, it is going to be a trialkyl amine. That is, if for see for mixed one, if R1 is not equal to R2 which is not equal to R3 students, it is going to be your alkyl amine, and all these three alkyl group, they have to be in which order? They have to be in alphabetical order. Now students, here what you say, IUPAC name is going to be N, N dialkyl alkane amine. Yes, it has to be dialkyl alkane amine, and for mixed one it will be N-alkyl. The shortest one will be over here, then the one which is having more carbon than that, and the longer one will be over here students. It is going to be in this particular way. Yes students, so here what we have done is we have talked about what students? We have talked about their nomenclature. We have talked about what? Their nomenclature: alkylamine, alkanamine, dialkylamine, N-alkyl alkanamine, and then there is trialkylamine, N-dialkyl alkanamine. So students, here what we have seen is we have talked about what? Their common name. Common name is going to be what? It is going to be your alkyl amine. In case of mixed amine, the name of alkyl groups are written in which order students? They are written in alphabetical order. If two or three identical groups are attached to nitrogen, what you are going to do? You are going to use di or tri prefix before what? Alkyl group. Okay, and then students, here If it is aromatic amine that is aryl amine is named as aniline, and other aromatic compounds are considered as derivative of what? Aniline. So students, in IUPAC name, primary amines are named by replacing the ending E of parent alkane by what? Amine. So it becomes what? It becomes alkane amine. And then students, suppose here it is like this, it is CH3, CH2, CH2, and then there is NH2. So students, what you are going to do? You are going to call the name as what? This is going to be your propan, and then here you write it as what? You write it as 1-amine. So the name is going to be what? It is going to be propan 1-amine. Yes students, now what I am going to do students, I say secondary and tertiary amine, they are named as N substituted derivative of primary amine. Largest alkyl group is attached, attached to nitrogen is taken as parent alkane, and the other groups are considered as N substituent. And while naming students aryl amine, the ending E of the arene is replaced by what? It is replaced by what? Your amine students. Yes students, now what I am going to do is the next case which we are going to talk students, here it is. Okay, so students, here what we are going to do, we are going to talk about the examples. Let us see with the examples of this particular part over here. Okay, so these are the examples of your amine students. Yes, so here students, we have talked about what? Common and IUPAC name of some alkyl and aryl amine. See, yes, this is primary amine, so you say this is methylamine, and then here it is methanamine. Okay students, and then see here likewise students, if I am talking about secondary, it is dimethylamine. It is going to be what? It is going to be a dimethylamine. It is N-methyl-methanamine. Okay, and then students, here students, you write it as trimethylamine. There are 3 methyl groups, so it is trimethylamine, that is going to be your N, N dimethyl methanamine. So students, this is all about what? The nomenclature. There are other examples also which we can see, which you are supposed to do. Now here students, the next is going to be the method of preparation. So here under preparation of amine, what I am going to do is the very method for preparing amine is going to be what? You say it is going to be by ammonolysis of your alkyl halide. The very first method is going to be what? It is going to be ammonolysis of alkyl halide students. See students, what happened with this ammonolysis of alkyl halide? So what you do, you take over here, see this is going to be what? This is going to be your alkyl halide. You react it with whom students? You react it with alcoholic ammonia. So this is going to be your alcoholic ammonia, and here this has to be primary greater than secondary greater than what? Tertiary. So students, here it will undergo which reaction? It will undergo nucleophilic substitution reaction. So where what is going to happen? The halide will be replaced by what? It will be replaced by amino group. So you are going to get something called as this one over here students. This is going to be your primary amine. Yes, it is going to be what? It is going to be your primary amine. Yeah students, this is going to be your which amine? You call it as primary amine, along with what? Along with hydrogen halide. Now students, if we have taken alkyl halide in excess, this primary amine will again react with what? It will again react with alkyl halide. Okay, see now here this was acting as a nucleophile. Now this is going to be a stronger nucleophile because here there is an electron donating alkyl group attached. So students, again what is going to happen? This hydrogen atom will be replaced by alkyl group. So here you say you will be getting something called as this one, which is secondary amine, along with what? Along with your hydrogen halide. And here this secondary amine when reacts with alkyl halide, you will get what? You will be getting your tertiary amine. This tertiary amine, it will further react with whom? It will further, see students, this tertiary amine, you say this tertiary amine, it will further react with what? It will further react with alkyl halide to give you what? R4N plus and X minus, which is going to be your quaternary ammonium salt. What is this? This is going to be your tertiary amine, and the upper one is going to be what? It is going to be your secondary amine. So students, here you say this method is known as what? It is known as your ammonolysis of what? Alkyl halide. Yes, it is called what? Ammonolysis of alkyl halide, where the halide of ammonia is replaced by what? It is replaced by amino group. So you get primary amine. Primary amine reacts again with alkyl halide to give you secondary. Secondary again reacts with alkyl halide to give you tertiary, and tertiary again reacts with alkyl halide to give you quaternary. So students, if you have taken alkyl halide in excess, your major product is going to be QAS. And if you take ammonia in what? In large amount, then your main product is going to be what? It is going to be your primary amine, students. Yes, students, then the main product is going to be which amine? It is going to be primary amine. So students, here they have said that when alkyl group is heated with excess of alcoholic ammonia, it will undergo nucleophilic substitution reaction in which hydrogen atom is replaced by which group? Amino group, to form primary amine. Now students, why it is known as ammonolysis? Because there is breaking of carbon halogen bond by ammonia. So you call it as ammonolysis. It is also known as alkylation of ammonia, because here the hydrogen atom of ammonia is getting replaced by alkyl group. It is carried out at about what? 373 Kelvin, students. So here students, this is how it goes. Now here they say if alkyl halide we are taking, students, what is going to be the order of reactivity of alkyl halide? It is iodide greater than bromide greater than what? Chloride, students. Okay, now students, the next case which we are going to talk over here is, see, one important thing which you are supposed to note, students, that your alkyl halide should never be tertiary. Alkyl halide should never be what? It should never be tertiary when you are reacting it with what? When you are reacting it with alcoholic ammonia. See students, if alkyl halide is tertiary like this, if it is CH3, CH3, and here there is going to be what? See students, here what I am going to do? I am going to call it as CH3. Here there is going to be CH3, and here it is going to be your Br. And then there is going to be what? There is going to be your alcoholic ammonia. Okay. Now students, here instead of nucleophilic substitution reaction, it will undergo elimination, because it is becoming difficult for the nucleophile to come and attack at this particular carbon. See, it is becoming difficult for the nucleophile to come and attack at this carbon. So instead what it is going to do is, see students, it will approach, see this is alpha carbon, this is beta. So it will approach for the hydrogen atom of what? Beta carbon. So what you will get is, you will get, see, here it is double bond CH2, here it is going to be CH3 over here. From alpha carbon Br is lost, and from beta carbon H is lost. So what you are going to get is, along with that you are going to get something called as what? Ammonium bromide. And here the product formed is what? The product formed is going to be your alkene. So the care should be taken that alkyl halide is not tertiary, because it will undergo elimination instead of what, students? Instead of your substitution. Now students, the another method to prepare what? To prepare your, see, the another method to prepare amine is going to be by reduction of nitro compounds. See students, here there is nitro compound. See, this is nitro compound. When you carry out its reduction, see what you are going to get? You are going to get amine. And this reduction can be done by using metal acid mixture, or by using catalytic hydrogen, or by using lithium or aluminum hydride in what? Ether. So that is going to be our second method. Now students, one more method over here to prepare what? To prepare this particular amine is going to be what? It is going to be by reduction of what? Cyanide. See students, it is going to be by reduction of cyanide, that is alkyl nitrile. So here what we are going to do is, students, we will take cyanide. When you treat it with hydrogen, there is cyanide. When you treat it with hydrogen, what is going to happen? 2 hydrogen will be getting added over here, 2 will be getting added over here, you will be getting which amine? You will be getting primary amine. See, this sodium in alcohol is known as Mendes, see, it is Mendes reagent. So the reaction which is carried out, see students, you know, process of adding hydrogen is called reduction. So your reduction is carried out by using Mendes reagent. So it is going to be Mendes reduction. It can be also carried out by using what? Lithium aluminum hydride. One of the important thing of this particular reaction is what? If you are using methyl cyanide, you will get ethyl amine. Means what? The length of the carbon chain is going to increase by what? It will increase by 1 unit, students. Yes. Now students, here the next case over here, see what we are going to do is, now the next method is going to be by reduction of what? By reduction of amide. Now what happens with this reduction of amide? See students, amide, see, on reduction by using lithium aluminum hydride in ether or by using sodium in alcohol, it is going to give you amine with same number of carbon. See, with same number of what? Carbon. So here there is acetamide, it is getting converted into what? It is getting converted into your ethyl amine. So primary amine having same number of carbon atom can be obtained by reduction of amide. So students, this is going to be one method where what you do, you convert this carbonyl group into what? Into CH2 group over here by reduction. 2 hydrogen will be added over here and 2 hydrogen will be moving with what? With O as what? H2O. Okay, so this is how it goes. Now students, we are going to talk about our Gabrielthalimide synthesis. Yes students, here what we are going to do, we are going to talk about Gabrielthalimide synthesis. Now what happens in this Gabrielthalimide synthesis? See, this is Gabrielthalimide. You treat it with alcoholic ammonia. So students, here N will be taking the electron of H. Okay, so this K plus will combine with this N and you will get salt. That salt is treated with what? Alkyl halide. So here this potassium and halide is moving out. So what you are getting? You are getting N-alkyl thalimide. You are getting N-alkyl thalimide. Now this N-alkyl thalimide is when treated with NaOH. So students, what is going to happen? Here there will be one H, here there will be one H, and here it is going to be ONA, and here also there is going to be ONA. So students, what you will get is, you will be getting your primary amine. Students, aromatic amine, this is going to be very important students. You say aromatic amine cannot be prepared by this method. Why aromatic amine cannot be prepared? Because aryl halide do not undergo which reaction students? It do not undergo nucleophilic substitution reaction with the anion formed by thalimide. Now students, the another very method which I am going to talk over here, it is going to be by half months degradation. Okay, by half months degradation, which is also known as half months rearrangement. It is also known as half months bromamide degradation, yeah, or you may say half month hypobromamide degradation. So various name for this particular reaction. Students, here what happens, there is, when you take amide, you are treating it with what? You are taking amine over here. Yes students, you take amide over here. When you treat it with bromine in alkali, when you are going to treat it with whom? Bromine in alkali, so there will be rearrangement reaction. This alkyl group will migrate from carbonyl group to nitrogen. So what you will get is, you will be getting primary amine containing what? Containing one carbon less. Containing one carbon atom less than what? Than amide. Than what? Than amide over here. Okay, so you say it is a good laboratory method for conversion of amide into amine containing one carbon less. See students, when we were carrying out reduction of amide, you used to get same number of carbon atom in amine. Okay, see this is a reaction where the length of carbon chain is going to decrease by what? It is going to decrease by 1 unit. So you call it as step down reaction. You are going to call it as which reaction, students? See, as it is written over here, there is removal of CO group from amide. As a product contain one carbon atom less than original amide, it is known as step down reaction. So students, what I can do is, what I say is, if you have amide with you and you carry out what? You carry out rearrangement. If you are carrying out what? It's rearrangement. What you are going to get is, you are going to get amine with one carbon less. And if I carry out what? Students, if I carry out their reduction, you will be getting amine with same carbon. Amine with what? Amine with same number of what? Of carbon atom, with same number of carbon atom. So students, here we have completed with what we have done with their methods of preparation. So students, after Hoffman bromamide degradation reaction, or you say rearrangement reaction, now we are moving toward physical properties of amine. Now students, under physical properties of amine, we say there is intermolecular forces, then there is going to be boiling point, and you say solubility. Students, what we say is, this NH bond in amine is polar. Why it is polar? Because of what? Difference in electronegativity. So they say polar nature of NH bond. What you say? You say primary and secondary amine have intermolecular hydrogen bonding. So what we have said, students, they say NH bond in amine is what? It is going to be polar. Why it is polar? Because of difference in what? Because of difference in electronegativity of nitrogen and what you say? Hydrogen. Now due to polar nature of which bond? NH bond, primary and secondary amine, they form intermolecular which bonding? They are going to form intermolecular hydrogen bonding. And this intermolecular hydrogen bonding is to be greater extent in what? In primary amine than you say secondary amine, because primary amine has what? It has two hydrogen atom bonded to nitrogen atom for what? For hydrogen bonding, students. Yes, now what we will say is, this is the hydrogen bonding which we have seen over here. This is going to be hydrogen bonding. See, this is going to be one primary amine, this is going to be another primary amine, this is going to be another primary amine. So here the H of one primary amine is forming what? Hydrogen bonding with the N of another primary amine. Yes students, so you say primary amine is going to form more hydrogen bonding, whereas tertiary amine do not have intermolecular hydrogen bonding. Why? Because there is no hydrogen atom. Tertiary amine is this. So you say there is no hydrogen atom or nitrogen atom of tertiary amine. Okay, but due to polar NC bond, see, due to polar NC, see, this is N and alkyl group is nothing but what? C. So you say it is going to have what? Intermolecular dipole attractive forces. See, it is not having hydrogen bonding. So you say tertiary amine do not have intermolecular hydrogen bonding, as there is no hydrogen atom or nitrogen atom of what? Tertiary amine. But due to what, students? Due to polar NC bond, tertiary amines are polar molecule and they have intermolecular dipole attractive forces. Okay, now students, the another case is going to be what? You say intermolecular forces of attraction are strong in what? They are going to be strong in primary amine because it forms hydrogen bonding, and it is going to be weakest in what? Tertiary amine, because it forms this dipole attractive forces, students. Yes students, now they say the next point which we are going to understand, students, another physical property is going to be like this. What is going to be the boiling point? The one which forms more hydrogen bonding will be having higher boiling point. So you say the boiling point of isomeric amine is going to be, primary is having more boiling point than secondary, and secondary is having more boiling point than what you say? Tertiary. Okay, now students, what we say, aliphatic amines are what? They are gases with fishy odor, and middle amines are liquid, whereas higher ones are solid under ordinary conditions of temperature and what you say? Pressure. Now students, when we talk about aniline and other aryl amine, they are usually what? They are usually colorless, but they get colored as they get. So students, we say aniline and other aryl amines are usually what? They are colorless liquid, but they get color as they get easily oxidized by what? Easily oxidized by air. Now what we say, due to the ability of forming hydrogen bonding with water, you say lower aliphatic amines are soluble in water, but the solubility of amine, you say the solubility of amine is going to decrease with increase in molar mass of amine due to increase in the size of alkyl group. So students, what we say, the solubility always is going to decrease with increase in molar mass. Okay students, so what we will say is the NH bond in amines are less polar than OH bond in alcohol. So solubility of alcohol is more as compared to amine, and amine is more as compared to what? It is more as compared to your alkane. If you are comparing it with carboxylic acid, you say carboxylic acid will be more than alcohol, alcohol will be more than amine, and amine will be more than what? It is going to be more than alkane. In other words, you can say alkane is less than amine, amine is less than alcohol, and alcohol is going to be less than your which acid students? It is going to be less than carboxylic acid. Now students, here what we are going to do is we are moving toward what? We are moving toward basicity of amine. Now what happens with this basicity of amine? You know amines are basic in nature. Why they are basic in nature? Because of what? Because of the presence of lone pair of electron on what? On nitrogen atom. So because of Lewis theory, you know Lewis theory, Lewis acid donate electron, Lewis acid take electron. So Lewis base is going to what it is going to do? You say students, this Lewis base is going to what? It is going to donate electron. Lewis acid take electrons, and Lewis base is going to what it is going to do? It is going to donate electrons. See students, if you see carefully over here, M3N is an amine. Here it is having lone pair on N. It is donating its electron to what? A Lewis acid over here, which is going to be what? Which is going to be BF3. And what you get? You get salt. Yes students, now this basic strength is expressed in terms of what? KB, and the another one is going to be PKB. See students, larger the value of KB, larger the value of KB, more is going to be what? More is going to be the basic strength. Okay, larger the value of KB, more is going to be what? Basicity is going to be what? It is going to be more students. And what you say, if PKB, see smaller the value of PKB, basicity is going to be what students? You say basicity is going to be more. So these are the points which you are supposed to remember. Okay, so if KB, dissociation constant of base, is more, basicity is going to be what? It is going to be more. And if PKB is going to be less, then to basicity is going to be what students? It is going to be more. So you say PKB value is smaller. See, when KB value is large, PKB value is going to be what? It is going to be smaller, and more is going to be what? More is going to be your basic strength students. Now students, here what we are going to do students, we are going to compare basic strength of aliphatic amine. Now what is going to be the basic strength of aliphatic amine? Students, here what is going to happen? We have been saying N is having lone pair. When it donates lone pair, it is going to be basic. So if there is alkyl group attached to what? If there is alkyl group attached to N, okay, more number of alkyl groups, so they are going to donate, alkyl group will be donating its electron to N by positive inductive effect. So there will be more number of electron on N for donation. So tertiary amine will be more basic than what? Than your secondary amine. And secondary amine is going to be more basic as compared to what? Primary amine. And primary amine is going to be more basic as compared with what? As compared with ammonia. So students, this is true in which phase? In gaseous phase. Okay, in gaseous phase. Whereas in aqueous solution, okay, so we students, what we say, in aqueous solution, here in aqueous solution, what is going to happen? Secondary amines are going to be the strongest base. Why? Because students, two factors take place over there. There are two factors which are going to take part. Students, what we have been saying? We have been saying in gaseous phase, yes, in gaseous phase, what is going to happen? Your tertiary amine is going to be more basic as compared to secondary, and secondary is going to be more basic as compared to primary. Whereas in aqueous phase, you say in aqueous phase, what is going to happen? There are two factors students which are going to, which we are supposed to consider. One is going to be what? One is going to be steric hindrance of alkyl group. Yes, one is going to be what? It is going to be steric hindrance of which group? Of your alkyl group, and the another one is going to be what, students? It is going to be your solvation effect. Yes, it is going to be which effect? It is going to be your solvation effect. Now students, this due to these two effect, basicity is going to be what? Secondary will be more basic as compared to what? As compared to primary. Primary will be more basic as compared to tertiary, and tertiary will be more basic as compared to ammonia. Yes students, so this is going to be the part over here. This is going to be the basicity. Now students, the another one more important thing over here, when we are comparing our aliphatic amine with what? With aromatic amine, what is going to happen? Aliphatic amine is an electron donating group, so this will be more basic over here as compared to this, and this is going to be what? This is going to be less basic, because this is going to be what? This is going to be an electron withdrawing group, whereas here R is going to be what? It is going to be your electron releasing group, or you say it is going to be electron donating group. So students, this is going to be the order of what? You say this is going to be your order of basicity. Now students, after this basicity, the next part which we are going to talk is going to be about something called as this one. Yes students, we are moving toward chemical properties of what? Of amine, and here we are going to talk about laboratory test for amine. Now test for primary amine as what base? The students, all bases, whether it is all amine, primary, secondary and tertiary, they are basic compound. So the aqueous solution of water soluble amine turns what? They are going to turn the red litmus into what? Into blue. And the basic nature of amine is detected in laboratory with what? Aqueous solution of strong mineral acid. As you put a mineral acid in it, it is going to form what? It is going to form your salt. The water insoluble amine dissolves in HCl to form water soluble substituted ammonium chloride. Okay, so students, this is going to be the case over here. Now the next test, it is going to be diazotization reaction, or your a dye test. You call it as which test? You call it as dye test. Now students, here what you do, you take aromatic primary amine. To that you will be adding concentrated HCl and NaOH. Okay, and the solution is transferred to a test tube containing beta naphthalene NaOH. So here what is going to happen? There will be what? Formation of orange dye, and it is indicating what? It is going to indicate the presence of aromatic what? Aromatic primary amine. So this is going to be another test, students, over here. Now students, the another important part which we are going to talk is going to be about alkylation of amine. Now what happens, as the name suggests, alkylation of amine, you call it as amines. H will be replaced by which group? It will be replaced by alkyl group. See here it is RNH2, students. If you see carefully, here it is RNH2. Here the H has been replaced by alkyl group when you treat it with alkyl halide. So you get what? You get secondary amine. Secondary amine again when reacted with what? Alkyl halide, it will give you tertiary amine, and tertiary amine when reacted with this, it is going to form what? It is going to form something called as this one, that is R4N plus X minus, students, that is going to be what? Your tetra alkyl ammonium halide. So students, here when primary amine is heated with excess of primary alkyl halide, it is going to give you secondary amine, tertiary amine, along with what? Tetra alkyl ammonium halide. So students, if excess of alkyl halide is used, tetra alkyl ammonium halide is obtained as a major product. So here you are using alkyl halide in excess. You are carrying, H has been replaced by alkyl group. So students, this process is also known as exhaustive alkylation of amine. Now students, this R4, see here you say R4N plus and this X minus, tetra alkyl ammonium halide, they are quaternary ammonium salt, and they are going to be crystalline solid. They are considered as what? They are considered as derivative of what, students? They are considered as derivative of your ammonium salt, in which all the 4 hydrogen atom attached to what nitrogen atom are replaced by which group? They are replaced by 4 alkyl group. Now students, primary amine, if you want to convert it into tetra alkyl ammonium halide, it will consume some 3 moles of alkyl halide. Secondary, it will consume 2 mole, and tertiary, it will consume only 1 mole of alkyl halide to convert it into what? Quaternary ammonium salt. Now students, here lots of HX is formed as byproduct over here. So what you say is, you say the reaction is carried out in the presence of mild base to neutralize the excess of HCl formed, or you say HX formed. And students, if alkyl halide is methyl iodide, the reaction is called what? It is called exhaustive methylation of amine. So here methylamine, you are treating it with methyl iodide. Finally what you get is, you get tetramethyl ammonium iodide over here. Yes students, now what we are going to do is the next part over here. Yes students, here what we say, here we have something called as Hoffman's elimination reaction. Now what happens with this Hoffman's elimination reaction? Students, you will be taking over here something called as this one. There is R4N plus, and then there is going to be what? It is going to be X minus. Now what you do? You treat it with what? You treat it with AgOH. Which one? Aqueous wala. Yes, so from where you get this AgOH? When you treat Ag2O with what? With water. Yes students, when you treat what? Ag2O with what? With water, you are going to get AgOH. And this AgOH, see, it will be replacing the X. So you will get R4, here it is going to be N plus, and here it is going to be what? It is going to be your OH minus. Now students, here what is going to happen is Hoffman's elimination. What is going to happen? Here there is going to be something like this. This is 3 times, here it is N, here you write it as CH2, CH3. Okay, this everything is going to be what? It is going to be positive, and here it is going to be OH. Now students, what is this? This is your alpha carbon, and this is going to be your beta carbon. When you are heating it, so it will undergo beta elimination. It will undergo beta elimination. Yes, it will be undergoing beta elimination to give you what? To give you something like this, R3 thrice N. Okay, R3 thrice N, along with what? See students, from alpha carbon, this complete group is lost, R3 thrice N. And then here it is going to give you what? It is going to be H2 double bond, CH2 double bond, CH2. And then along with that, what you are going to get? You are going to get water. What is this? This is going to be your ethene. You write it as what students? You are going to call it as your Hoffman's elimination reaction over here. Yes, this is going to be your Hoffman's elimination reaction. What we do in this Hoffman's elimination reaction? So there is going to be quaternary ammonium hydroxide. On strong heating, it will undergo beta elimination to give you alkene, and this reaction is called what? It is called your Hoffman's elimination reaction. So students, here we are going to talk about acylation of amine. Now what is going to be this acyl group students? You say RCO is going to be your acyl group. Now when hydrogen atom present on nitrogen atom of amine is replaced by acyl group, then students, you call that reaction as what? You are going to call it as your acylation reaction. So students, here what you are going to do? You have something like this over here. Okay, you are treating it with what? You are going to treat it with what? Your acyl chloride, let us say. Students, here you can see, you can treat it with acyl chloride, or you can use something like this. This is going to be your anhydride. Yes, this is acyl chloride, and this is going to be your acid anhydride. Now students, see what is going to happen. The H from here will be replaced, and what you will be getting? You will be getting RNH. Here it is going to be CO, and here it is going to be R. And then students, if it is this one, the product is going to be HCl. If you are using acyl chloride, byproduct is going to be HCl, and if you are using this acid anhydride, byproduct is going to be what? It is going to be your carboxylic acid. Students, now we are interested more in this. See, here the hydrogen atom which was present has been replaced by what? It has been replaced by acyl group. Now the compound formed is called what? It is going to be your amide, students. So students, here what we will say, aliphatic and aromatic primary and secondary amine will undergo acylation. Why not tertiary, students? Because tertiary amine is not having hydrogen on nitrogen to be replaced. So students, aliphatic and aromatic primary and secondary amine undergo acylation reaction, and these amine contain replaceable hydrogen atom on nitrogen atom. Okay, hydrogen atoms are replaced by which group? They are replaced by acyl group such as acetyl group. On replacing with what? On reaction with your acetyl chloride, or you say acetic anhydride. So acetyl derivative of amine is obtained. That is called what? That is called your amide. And students, you know amide is less basic than what? It is less basic than amine. See, if you see carefully, see why it is less basic. N is having lone pair over here. See, this is going to be which group, students? This is going to be your electron withdrawing group. So it will withdraw electron by what? By resonance. Okay, if I just want to show that particular effect, students, we can put it in this particular way. See, we are going to show that effect that amides are less basic. So it is NH, here it is C double bond O, and here there is going to be R. So here this will be taking electron, and this electrons will be moving over there. So by resonance, what you will get? You will get RNH. Here it is positive charge, here there is double bond, here it is O minus, and here it is going to be R. See students, if you see carefully, N has got positive charge due to resonance. So you say it is less basic, and this reaction is going to be what? It is a nucleophilic substitution reaction. It is carried out in the presence of strong base like what? Pyridine. Why? To neutralize what? The acid by a product over here. Yes students, here ethylamine is reacting with ethanol chloride to give you what? To give you something called as N-ethyl ethanamide. See, this is N-ethyl, okay, N-ethyl, and then there is going to be what? It is going to be your ethanamide. Yes students, this is going to be about what? This is going to be about your acetylation of amine. Now the other thing which we are going to talk, students, it is going to be your carbyl amine reaction. Yes students, you are going to write it as which reaction? You are going to call it as carbyl amine reaction. Now what happens with this carbyl amine reaction, students? You have aliphatic or aromatic primary amine. Here I have taken aliphatic. I am treating it with what? I am going to treat it with chloroform in the presence of alcoholic KOH at some temperature. So what I will be getting? I will be getting alkyl isocyanide, which is called what? Which is called carbyl amine. And here along with that, what you are going to get, students? You will be getting something of this particular type. So this carbyl amine is going to have what? It is going to have offensive odor, unpleasant odor. Okay, and this test is given only by what? Only by primary amine. Okay, secondary and tertiary amine is not going to give this particular test, students. Yes, so you say aliphatic or aromatic primary amine on heating with chloroform, is going to give you offensive smelling or a compound called alkyl or aryl isocyanide or carbyl amine, and this reaction is used as what, students? It is used as a test for what? It is used as a test for your primary amine. Secondary and tertiary amine do not give this test. This is important, students. Now here, students, what we are going to do? We are going to talk about reaction with nitrous acid. See, primary, secondary and tertiary amine, they are going to react differently with nitrous acid. Now what is this nitrous acid? You say nitrous acid is going to be your HNO2. It is obtained by reacting NaNO2 with what? With your dilute HCl. At what? At 0 to 5 degree Celsius. At what, students? At 0 to 5 degree Celsius. Now what is going to be the reaction? Nitrous acid is unstable, so it is prepared whenever you require it. It is freshly prepared because it will get decomposed. Now students, what is the reaction of nitrous acid with primary amine? So you say aliphatic primary amine on reaction with what? Nitrous acid. It is going to form disonium salt, which is going to be unstable. So it will decomposed, okay, by reaction with the solvent water. And what is going to happen? Alcohol is formed as a product and nitrogen gas is evolved, students. See, this is your primary amine. You are reacting it with nitrous acid. Okay, you are reacting it with what? You are reacting it with nitrous acid, primary amine. So what you are getting? You are getting Rn2 plus and OCl minus. Then you treat this one with water. See students, when you treat it with water, here it is going to be OH and here it is going to be your H. So you will get alcohol along with nitrogen gas, and then there is going to be your HCl. Now students, the same reaction when it is carried out with aromatic primary amine, it is going to give you what? It is going to give you a disonium salt, okay, which has reasonable stability at what? 0 degree, they say 0 degree Celsius, that is 273 Kelvin, students. Yes students, now here what we are going to do is the another part, students, which we are going to understand. Now what is going to happen with this disonium salt? Students, we are going to carry out two type of reactions of this disonium salt. See, diazonium salt, yes, you say diazonium salt, it will undergo two types of reaction. One is going to be reaction involving replacement of disonium group, reaction involving what? Replacement, yes, replacement of disonium group. And another one is going to be what? It is going to be reaction involving retention. It is going to be reaction involving what? Retention of diazonium group, students. So here students, what we have shown is, we say aryl disonium salt are what? They are resonance stabilized. They are what? They are resonance stabilized. Now first is reaction involving replacement of diazonium group. So students, here this is arene disonium salt. When you replace this disonium group by chloride or bromide by reacting it with CuCl or CuBr in the presence of HCl or HBr, then that particular reaction is called what? It is called Sandmeyer's reaction. You can even replace this disonium group over here. See students, here this disonium group has been what? Here what you will say, you will put it in this particular way. Students, here the disonium group can be replaced either by chloride, bromide, or you say cyanide. Then you are going to call it as what? You are going to call it as Sandmeyer reaction. Now what happens in Gattermann's? Disonium group will be replaced by chloride and bromide, but the reagent is copper powder in acid. If you want to replace it by chloride, you are supposed to use HCl. If you want to replace disonium group by bromide, you are going to use what? HBr. Now students, if you want to form idoarene, so you are going to heat it with potassium iodide. So this, it will be replaced by I. If you want to replace disonium group by what? H. So you are going to treat it with hypophosphorus acid, or you say your ethanol. What is going to happen? This group will be replaced by H, and what you are going to get? You are going to get arene along with byproduct like N2H3 PO3. Okay, and here the byproduct is going to be your acetaldehyde. Now phenol formation, what happens students? This will be replaced by what? OH when you heat it with what? When you heat it with water. Yes students, now you say reaction involving which group? See, one more reaction students here. Reaction with fluoroboric acid. If you take this one, see arene disonium chloride, and you react it with fluoroboric acid, it is going to form arene disonium fluoroborate. It is going to form what? Arene disonium fluoroborate. If you heat it, you will get aryl fluoride along with N2 and what? BF3. And if you heat it with copper, you will get aryl, this nitro alkane, and here what you are going to get? You are going to get nitrogen along with BF3. Students, here what we have done is, we have done two reaction over here. In one, we have replaced this disonium group with what? Fluoride, and another what we have done, we have replaced it with what? Nitro group. Now students, here it is going to be reaction involving retention of diazonium group. Here it is going to be reaction involving what? Retention of diazonium group over here. So students, here this arene diazonium salt when treated with certain reactive aromatic compound like phenol or you say aromatic amine, it will give you what? It will give you azo compound. Now this azo compound, they have extended conjugation because of which they are going to be brightly colored, and students, you say they are used as what? They are used as dye. And this is going to be an example of which reaction? It is going to be an electrophilic substitution reaction. See students, if I just want to show this reaction, I will write it as what? This is going to be my arene diazonium salt. I'm going to treat it with what? I'm going to treat it with phenol, let us say. See, this is going to be your phenol. This is ortho position rich in electron, and this is going to be para position. So it will attack at para position. So electrophilic substitution is taking place. Why not at ortho position? Because there will be hindrance, students. So here you get what? You will get something of this particular type, students. You will be getting something of this particular type. See, this is going to be what? This is going to be your para hydroxy azo benzene. Okay, it is going to be what? It is going to be an orange color dye, students. It is having extended conjugation, double, single, double, single, double, single, double, like this. Because of what? You say it absorbs lots of light from the visible region, and hence it is going to be what? It is going to be brightly colored. Yes students, now the similar type of reaction which we are going to understand over here, students, it is going to be, okay, so here students, what we are going to do, the similar reaction over here is going to be with what? With aniline. Here you take diazonium salt, this diazonium group is going to attack over here, so you will get para-amino azobenzene, which is going to be what? Which is going to be an yellow dye, and HCl is formed over here. Yes students, so this is going to be one reaction. Now students, here differentiating reaction with Hinsberg's reagent, which is going to be your benzene sulfonyl chloride. Your primary amine, students, when it is reacting with your Hinsberg's reagent, it is going to give you what? See what is happening, students, this H and Cl is lost over here, so you will get some N-ethyl. See, this is N-ethyl. Here it is benzene sulfonamide. Yes, benzene sulfonamide. Now this is soluble in alkali. Why? Because N is having H over here. So this N is going to take the electron of H toward itself. So it is soluble in what? It is soluble in alkali. The hydrogen atom attached to nitrogen atom in sulfonamide is what? It is strongly acidic. Therefore it is soluble with what? Alkali. Now students, similar type with what? With your secondary amine. Secondary amine will react with what? Benzene sulfonyl chloride to give you NN. See, here you are going to get something like this. You are going to get this NN diethyl benzene sulfonamide, but it does not contain any hydrogen atom attached to nitrogen. So you say it is not acidic, so it will not dissolve in what? It will not dissolve in alkali. And students, here what was happening is primary amine you have taken, you have added Hinsberg's reagent to it. So you used to get what? You used to get some salt. In that, when you add alkali, see, first primary amine mein Hinsberg's reagent is soluble, and then when you add alkali, that is also soluble. Tertiary amine, only Hinsberg's reagent is soluble, alkali is not soluble. And in tertiary amine, what is going to happen? Even Hinsberg's reagent is not soluble. What is the reason? Tertiary amine does not react with benzene sulfonyl chloride, because there is no hydrogen atom present on what, students? On your nitrogen atom. Now here, students, I am talking about what? I am talking about something called as aromatic amine. Now aromatic amine mein, what you say, this amino group is going to donate its electron to the benzene ring, and it is going to make both the ortho and para position rich in electron. So you say it is going to be what? It is going to be your ortho para directing, and what you say, it is going to be your activating group, and it will undergo which reaction? See, it is donating electron to the benzene ring, so benzene ring is going to become rich in electron. So electron loving group will come and attack benzene ring. Okay, so you say it will undergo electrophilic substitution reaction. The very first reaction is bromination. So here this NH2 is powerful activating group. It is donating electron to the benzene ring. And now when you react this benzene, this aniline with bromine, it will undergo what? It will undergo ESR at both the ortho and 1 para position to give you what? To give you 2,4,6 tribromoaniline. Now students, suppose you don't want to prepare 2,4,6 tribromoaniline. So what you are going to do is, suppose you want to prepare only parabromoaniline. So students, what you will do, you will take aniline, you are going to treat it with what? You are going to treat with, see what we will do, we will convert NH2 to a group where N is not able to donate more electron to the benzene ring. So students, here the acetylation is taking place. H has been replaced by what? Acetyl group. Now acetyl group mein what is going to happen? It is what? The N is not having more power to donate electron because of the adjacent CO group over there. Now when you carry out bromination, it will be carried out only at what? Para position. It won't attack at what? You say ortho position due to steric hindrance, and you will get what? You will get your parabromoaniline. Now students, when I'm talking about nitration, direct nitration of aniline will give you ortho, it will give you para, but why we are getting meta, students? See students, nitration of aniline is carried out like this. This is your aniline. You treat it with what? You treat it with nitric acid, and here you take what? You take some sulfuric acid. You are going to take, students, what? You are going to take sulfuric acid. Now in the presence, see here you are going to get ortho along with what? Along with para, and why you are getting what? You are getting meta product also. Why meta? Because in acidic medium, some of the aniline is getting converted into what? It is getting converted into your anilinium ion, and this anilinium ion is what? It is going to be what? It is going to be your meta directing. You say it is going to be what? It is going to be meta directing. So students, this meta nitroaniline is also obtained. Yes students, this is the case over here. Aniline is there, you are carrying out its nitration, so you are getting para, meta and ortho. But what if you want to prepare only para? So again what you will do, you will try to convert NH2 to a group where it is not able to donate more electron to the benzene ring, and then you carry out the nitration. So you are going to get only one product. Yes students, now students, the another reaction which I am talking is going to be the sulfonation reaction. Here aniline is reacting with concentrated sulfuric acid to give you anilinium hydrogen sulfate. Yes students, it is going to give you what? It is going to give you anilinium hydrogen sulfate. When you heat it, you will get what? You will get sulfonilic acid, which is also known as what? It is also known as para-amino benzene sulfonic acid. Para-amino benzene sulfonic acid, students. Now due to the presence of both acidic and basic group, yes, due to the presence of both acidic and you say basic group, it can form internal salt. See, this is going to be what? This is going to be your internal salt, which is called zwitter ion. You may even write it as what? You may even call it as dipolar ion, students. You are going to call it as what? Dipolar ion. So here this H is moving toward this one. So this is ammonium and this is your CO3 minus. Okay, SO3 minus, sulfate, and then there is ammonium. So sulfonilic acid is going to exist as a salt called dipolar salt or zwitter ion. Why? Because it is produced by the reaction of acidic group and basic group present in the same molecule. And students, you call it as what? You call it as yes, you are going to write it as what? You are going to call it as internal salt, because within the same molecule acidic and basic groups are reacting and an internal salt has been produced. So students, with this we have completed with our revision of amine. Hope you all have understood with this particular part. Thank you for watching Study Live.